is a huge, huge lesson on derivatives. What it is, and it's a large part of calculus. Understanding how to find it, understanding where we use it, and so on. So here's your introduction to derivatives, but we will be spending a long time understanding it, understanding how to apply it, and so on. So understand this as an introduction, and that there'll be many, many, many chances to come back to try to understand this better and better. So what we just did before, our last lesson, the slope of a tangent line, is one of the definitions of what a derivative is. So the slope of the line tangent at that point, it's given a special name, and one of the definitions of a derivative is the slope of a tangent line. So the slope, not the equation of the tangent line, but the slope is called the derivative. And it has its own notation, really simple. There's a little tick mark that we put down beside f of x. That little line, sometimes we use the word prime, denotes derivative. Here, we did this to find the slope of the tangent line. That is the definition, the limit definition of a tangent. Excuse me. The process of finding a derivative is called differentiation. So if you talked about that word, differentiation, that means it's the act of taking the derivative. And the resulting equation is called the differential equation that you find. So here's your first time you've thought of derivatives. So first definition I want you to think of, what is a derivative? It's the slope of a tangent line. In other words, it's the slope using one point. And we already used the formula to find that slope, but now we have a name that we can give it, which is derivative. So what are some other notations you might see? You might see the one we just talked about, f prime, and often we use the word prime when doing this, so f prime at x. You might just see y prime. You might see dy by dx. Or you might just see something like this, where it's d, some function, that, and we say dy with respect to dx. But all of these notations are asking you to do the same thing, which is find the derivative. So the first one is, can we do it the long way? Find the derivative of each function, then evaluate it at x equals 2. So to find the derivative of this, it's the limit. So first of all, let's do notation here. So the derivative, f prime at x, is what? The limit as h approaches 0. It's x plus h, subtract f at x over h. Then we do some substituting in. So using the function 4x squared, so put in x plus h for x plus 3, subtract parentheses the function 4x squared plus 3 all over h. Keep using the limit notation. We're going to do some algebra here. So expand x plus h squared. So that's going to be x squared plus 2xh plus h squared plus 3. Distribute the negative or subtract sign. And now we're going to combine like terms. Now if I did it correctly, then only what has an h will remain. So 4x squared subtract 4x squared. So the 4x squares go. 4 times 2 is 8xh. 4 times h squared. Then we have 3, take away 3. And you're left with 8x plus 4h over 1. Plug in 0, and all you're left with is 8x. So the derivative of f at x is equal to 8x. That's what the derivative equals. What's the derivative at 2? That's how you'd write it down. The derivative at 2, plug in 2 for 8 or for x, and you get 16. All right, let's try that again. Number 2. How do I find the derivative? It's the limit as h approaches 0, and it's f at x plus h, subtract f at x all over h, plug in x plus h for x, subtract the function, all over h. Let's do some algebra, and we're doing it together, so we're good. So if I expand this, this would be x squared plus 2xh plus h squared plus 5h plus 3, and then plus x squared subtract 5x minus 3. Now, if I did this correctly, then only the h's will remain. So in this situation, negative x squared and positive x squared, they eliminate. We still have a negative 2xh. We have a negative h squared. 5x minus 5x eliminate. We have a 5h. And 3 take away 3 eliminate. We divide out the h's. And what I'm left with is negative 2x minus h plus 5. So when you plug in 0 for h now, you're left with negative 2x plus 5. That is the derivative. So the derivative of f at x at this point is negative 2x plus 5. Now what's the derivative at 2? Well, just plug in 2, and you get your answer for that. And that answer is 1. All right, next page. So again, our goal here is to find the derivative. So to find the derivative, it's the limit as h approaches 0. Now, I'm going to do this immediately to make it just a little bit shorter. I'm going to plug in x plus h wherever there's x. And then I'm just going to subtract the function. So I just did the first step. Took out the x, put in x plus h, take out the x, put in x plus h, and then subtract the function all over h. I need common denominators. So I'm going to use x plus 4 and I'm going to use x plus h plus 4, top and bottom. And then I'm going to combine like terms. So I have common denominators. I do need to multiply this out. So x times x is x squared. X times h is xh. 4 times x, 4 times h. Let's keep moving on over here. X times x is x squared, but it's a negative x squared. X times h would be a negative xh, and x times 4 would be a negative 4x. And that's all over the common denominator of x plus h plus 4, x plus 4, over h. This is the last of this. Then you're going to learn some shortcuts. All right, combine like terms. X squared minus x squared, done. Xh minus xh, that's done. 4x minus 4x is done. That leaves me with 4h, x plus h plus 4, x plus 4. And I'm going to go times the reciprocal right away. And notice the h's then divide out. Then you're going to plug in 0 for h. So wherever there's an h, plug in 0. So I have 4 on top. If I plug in 0 for h, I get x plus 4 and x plus 4. So that's x plus 4 squared. So there is my derivative. Then if I plug in 2, you get 4. 2 plus 4 squared, so that's 4 divided by 36, or 1/9. That's it. Now, you are going to appreciate this. So no more finding derivatives with limits, but you did need to know that what a limit is and how to find a derivative with a limit. But now we're going to do some rules or shortcuts to find derivatives so we don't have to do that each time. So here we go. If f at x equals x to the n, that means that n is some constant, then the derivative simply is n times x to the n minus 1. So we're going to practice that formula right now. So if I want to find the derivative of this using a shortcut, the power rule says that exponent, which is